Today we are talking about what is called a slope field. And a slope field is the graph of a derivative, okay? A graph of a differential equation, okay? Now, when you graph y equals 2x plus 3, does your graph go through every single point on the paper? No, it only goes through the points that satisfy it. What makes these different is that you are going to put graph on every single dot that's on this part. And each of these dots represents one unit, okay? So it says to sketch the slope field for each of the differential equations. We're taking all the stuff we've been working with for the last week and we're graphing it, all right? So let's take the first one. dy dx equals x minus y. What does that mean? That means the slope, dy dx, at any point is equal to the x-coordinate minus the y-coordinate. So the slope that you're going to draw is equal to the x-coordinate minus the y-coordinate. So let's start at 0, 0. What would x minus y be for that point? 0. What does a slope of 0 look like? Like this, right? Flat line. So at 0, 0, you are going to draw a little piece of graph with a slope of 0. Every point is going to have a line segment at it. And that line segment will be the slope that is calculated from the equation. Okay? Now, once you get one started, ask yourself, is there any other point on here that would have a slope of 0? Because a lot of times you will find patterns. What's another point that would have a slope of 0? 1, 1. So let's go to 1, 1, which is here. Draw a little slope of 0. When you draw these lines, don't make them too short. You've got to be able to see what their slopes are, but don't make them too long. Don't go any farther than halfway to the point on either side of it. Okay? Where else? 2, 2, right there. Doesn't go any higher than that. Does it work in the negatives also? Negative 1, negative 1? Negative 1 minus negative 1? That is 0. So yes, it does work down here. And then negative 2 does work right there. So all of those have the same slope. Okay. Once you find the pattern and you've filled up all of those, move over to another point. Let's move to this point here. What are the coordinates right here? 1, 0. What's the slope supposed to be? The slope is x minus y, so that would be a slope of 1. Okay? So, when you've got a slope other than 0, take the point where you're starting and just count the slope like a rise over run. So if I counted the slope up 1 and over 1, it would go through this point too. Also, correct? Yes. So basically, when you draw your little piece of line, have it point towards that point up there. So you would draw a piece of line like so, pointing to that other point that's up 1 and over 1 from the point that you're talking about. Okay? Is there any other point that would have a slope of 1? 2, 1, wouldn't it? 2 minus 1 is 1. So here's 2, 1. So this is going to have a slope of 1. Would the next one up here have a slope of 1? Yes, it would. 3, 2 has a slope of 1. What about down here? 0 minus negative 1. Yes, that's a slope of 1. So this one has a slope of 1, and so does that one. So the diagonals seem to be always having the same slope. That doesn't happen every time. Sometimes a horizontal group will have the same slope, or a vertical group. But this time it happens to be the diagonals. Okay, let's move over one more. Coordinates right here. 2, 0. What's the slope? Right here, I'm going to count up 2 and over 1. So the line I draw from here has to point towards that place right there. So I'm going to eyeball it, make it about like that. Okay? Since diagonals are following the same pattern, this one's going to have a slope of 2 also. However, I don't have 2 points up to point it towards. What's another way I can go? I could go down 2, couldn't I? Down in which direction would I need to go? Left. So make this dot point to there. So sketch it in like that. That's right. Okay. Do the same thing here. This one's supposed to have a slope of 2 at 1, negative 1. up 2 and over 1, so I'm going to point it towards there. And then this one also, up 2 and over 1, point it to there. Yeah, kind of. Now, one more thing I forgot to mention. Do you notice how all of these in the line that have a slope of 1, they all point towards each other? That is an asymptote, and I'll talk more about that, but it's an asymptotic behavior when they all line up like that. It's kind of a boundary line. Okay? Let's look at this right here. What are the coordinates right at this point? 3, 0. So it's got a slope of 3. 1, 2, I can't really do that one. This can go off the page, so I'm just have to guess. So it's steeper than this, so I'll go like that. This one I can do 1, 2, 3, and up 1. So like that. 1, 2, 3, and up 1. Like that. Wrote it myself. There we go. Okay. Yeah, what is its slope going to be for the next two? 4. That was 0, 1, 2, 3. These are going to be 4, so it's just steeper. Now we can just start guessing. 5 is almost going to be straight up and down. Like what? Christmas tree. All right. Now, let's go back to the other side of the horizontals. This one on the x-axis. Coordinates? Negative 1, 0. So what's the slope? Negative 1. So negative 1 goes this way. So I've got to go pointing towards that point. So it's going to go like that. So all of these are going to point this way. This is a graphic representation of a differential equation. We know what the equation looked like. Now we're looking at the graph. And I will talk about how it relates to real graphs in a minute. Okay? So this is negative 1. What do you think the next diagonal slopes are going to be? These were 0. These were negative 1. So these will be negative 2. Okay? So 0, 2. 0 minus 2 is negative 2. So down 2 and over 1. So I'm pointing towards that point right there. That one right there. That one right there. Just make them about the same. The next 3 here are going to have a slope of negative 3. 1, 2, 3. I'm going to have to estimate that one. That's negative 3. The next 2 are negative 4, so I'm just going to eyeball those, and then negative 5 going up. Okay. Has anybody seen something like this in the real world?
I think I've seen this before.
Yes, weather patterns. If you've ever looked at weather maps, depending on the channel that you watch, the Weather Channel will do this sometime, when they're talking about the flow of the jet stream, they might use these little pieces of graph to show the pattern of the wind. Okay? This is very common to what they use in weather. Huh? If you could graph it, you could make a graphic representation of it. Yes. Okay? So, this, like I said, is a graphic representation of a differential equation, the kind we've been working with the last 4 days. All right? So, all you have to find the slope, put the dots on there, or put the line segments on there. I want to skip number 2. Please, everybody in this class, hear me. Skip this one. Go to number 3. Okay? Because number 3 is actually going to graph something that looks familiar to you. So in this case, dy dx equals the opposite of x divided by y. All right. I'm going to bring in some scratch paper to do some math. Okay? We start at 0, 0. So that would be negative 0 over 0. What does that equal? I've heard some people say 0. Okay? I've heard some people say undefined. Would anybody believe that it would maybe equal 1? Infinity. Negative 1? Can you see negative 1? Okay. What's the rule that makes it equal 0? Whenever there's a 0 on top, supposed to be 0, right? 0 over 5 is 0. 0 over 10 is 0. Okay? But this one, what's the rule that says it should be negative 1? A number over itself is supposed to be negative 1. Okay? Undefined means there is no answer at all. No. I'm going to tell you right now, it's none of these.
Infinity.
Negative 0 over 0 is what we call indeterminate. Okay? N cannot be determined. Okay? It could be 0, it could be 1. It could also be 99. What? 0 over 0 is 99. Yes, it is. 0 over 0 is negative 2 also. Let me show you why. I like doing this with people. What is 16 divided by 2 equal?
That's 8.
That's 8, because the answer times the denominator equals the numerator. Agreed?
Yes.
Look up here. Does 0 times 0 equal 0? Yes. Forget the negative. Does negative 1 times 0 equal 0?
Yes.
Does 99 times 0 equal 0?
Yes. Oh, you're right.
Does anything times 0 equal 0?
Yes.
That's why it's indeterminate. You don't know what it is. It could be anything. Okay? So, indeterminate means it's actually not a no solution, but it's an infinite solution. Okay?
So infinity.
So it's infinity. It's almost infinity. Infinity is not a number. Infinity is the number of solutions that it has. The answer isn't infinity. The number of solutions is infinity. Okay. So since we don't know the slope right there, we draw nothing. Okay? Because there is a bazillion possible answers to this problem, we don't draw anything at 0, 0. We draw nothing. Because it could be anything. So let's move over. This point here is 1, 0. What is negative 1 over 0? Now, according to the rule I just taught you, could it be 0?
Yes.
Does 0 times 0 equal negative 1?
No.
No, can't be 0. Could it be negative 1?
No.
Negative 1 times 0 equal negative 1? No. What could it be? Okay. It actually can be nothing, because there is nothing that multiplies to 0 to give you negative 1. Think about it. Anything times 0 is always 0. So that's why this is no solution. That's what we call undefined. Undefined means there is no answer. How does a undefined, but this is an undefined slope. What does an undefined slope look like? Straight up and down, vertical line. So here, that one is vertical. So if you mathematically get undefined for an answer, the graph looks like this. No slope. What you learned in Algebra 1 is no slope, or undefined slope. Okay? Are there any other points that are going to have this for a slope? What about 2, 0? Yes. This one, and this one, and this one, and this one. See, that's why you knock them all out. Instead of doing every single pair of coordinates on the whole thing, you knock out as many that are alike as possible. Okay? Now let's do the y-axis. Coordinates right here are 0, 1. So negative 0 over 1 is 0, because 0 times 1 is 0. So this is a slope of 0. Horizontal, 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 horizontal. And now it looks like crosshairs on a scope. Those of you who hunt.
Call of Duty Spec Ops.
Oh yeah, or play Call of Duty. Yeah, hadn't thought about that.
I also play Call of Duty.
Okay, where do you want to go next?
1, 1.
Let's go to 1, 1. That's a nice easy point to do. When you plug in 1, 1 right here, negative 1. So that's a slope going this way, like so. Are there any other points with a slope of negative 1? Negative 1, negative 1. Let's go up here to 2, 2 first. You're right. You're both right. Then negative 1, and negative 2, negative 2. So those are all four the same. Okay? Let's go to the other diagonal and see if they happen to be the same. Let's go down here to this one. 1, negative 1. Positive 1. So it's going to go this way. Slope of 1 is always a 45-degree angle. It's an easy one to eyeball.
Isn't that one negative one?
That is the point 1, -1.
Oh, so it's negative.
So it's negative, -1, or actually 1 over -1 like that. 2 negatives make a positive. Okay? What about 2, -2? Is it going to be the same thing? Yes. So that's the same. And then up here, same thing, same thing.
Oh my gosh, it really does though. You know what
Okay.
So it shoots the photon
Now,
bomb.
I'm going to finish quadrant 1 for you, and then I'm going to let you loose to do the rest of this. Okay? So let's move over here. Coordinates right here. What are they? 2, 1. Some of you may need to write this down and may have trouble doing it in your head. So that would be -2 over 1, which would be -2. So at this point, we're going to go down 2 and write 1 and point it towards there. Now, diagonally, is that going to be the same slope? Let's check and see. What's the coordinates right here? That's 3, 2. That's not going to be the same slope, is it? No, it's -3 over 2. We can go ahead and do it, though. Okay. Now, I'm going to, because these are beautifully spaced, I can go over into the dots on the next graph. So it would be down 3 over 2. So I need to point it to here, like so. Yeah, I know it's a different graph, but that's okay. Okay, what about this one right here? This is 3, 1. So that would be -3. So from here down 3 and over 1. So I need to point it to there. And then this last lone little dot right here, this is 1, 2. So it's going to be -1 over 2. So that means I go down 1 and right 2. It's going to point over there. Okay? Now, I think almost every table in here has at least 3 people. What you can do is divide up the work. One of you take quadrant 2, one of you take quadrant 3, one of you take quadrant 4, do the rest of them, and then share with your group. And go ahead and fill this in. Okay? Then we'll talk about it and see if you see a pattern emerging. We'll just finish number 3.
So, Ms. Bell, how you put numbers into the parent -x over y, you pass through these points, right?
That's what I'm about to talk about. I'll show you how it all fits together. No, you're not. You're not. You're just the only one saying something about it. I'm about to show you. I'm about to show you. I want to finish the picture first, and then I'm going to show you. This is a graphic representation of all of the general solutions. Remember the general solutions? The plus C. The C is still in there. Okay. So this represents all the shapes that it could be. I'm going to do the math and show you.
Connect the dots all differently.
Yeah, just hang on, I'll show you. Okay, did everybody get something that looks pretty much like that?
Correct.
Okay, what shape do you see? I see circles.
It's what Luke uses to shoot the photon bomb into the hole of the Death Star.
Exactly.
Oh, I have to go watch that part again.
Except he doesn't use it because Obi-Wan tells him not to.
Turn it off. Okay, now, I want to show you what this is for, okay? So I'm going to take this equation And I'm going to do to it what we've been doing for the last 2 days. And that is to separate the variables. Okay? Now, take this equation, separate the variables. What do I do first? You don't have to write this down, just watch. Okay, dx goes there. Then what? Y goes to the other side. How? How do I move it? Multiply, so the y goes there. So now I have y dy equals negative x dx. Agreed? Okay, what do you do now? Antiderivative. Integrate both sides. What does this become? 1/2 y squared equals plus c. Okay. Now, if I wanted to clean that up, what would be the next step? Multiply both sides by 2. So that would be y squared equals negative x squared plus just a c. Okay. On the homework, I said you could stop right there, but I'm going to take it a step farther. Move the x squared over with the y squared. Look what you get. Positive x squared plus y squared. What equation is that? That's a circle. That's why this is circular. Okay, now, what this represents, and let me say it to everybody because I said it to a small group of people. This is a graphic representation of all of the general solutions to this equation. Basically, this gives the general shape no matter what C is. Now, if I told you that I wanted to go through the point 1, 1, could you tell me what the equation would be?
Nope.
How would you find C? You would just plug them in, right? So 1 squared plus 1 squared equals C. So C equals 2. So x squared plus y squared equals 2. What's the radius of that circle?
Square root of 2.
Square root of 2. Okay? Which is, the radius would be about 1.4. Now watch this. I need a pencil real quick. Can I borrow your pencil real fast?
Yes.
I want to be able to erase this. If I went to the graph and I put a dot at 1, 1, and then I followed the lines around in the direction they're pointing me, I would graph a circle with a radius of 1.5. Do you see that? That's what this is for. That's what this is for. Okay. Let me give you that too. All right. That's what this is for. Does that make sense? Okay. So whatever point I give you to start at, you put a dot there. Now the dot may not be exactly on one of these, but it kind of says, okay, go that way, and then you follow it till you get to the next one, and then it says, go this way a little bit, then go this way a little bit, and you work your way around, and it creates a circle. Sibby.
So then the very first one we did, what kind of equations?
This one is something that you've never seen before. What it happens to be is a graph that this is an asymptote. It comes around like this, and it comes down like this. It's a radi graph with a slanted asymptote. We did those last year. Something like that. Okay? Now, what I would like you to do is begin work on number 2. Okay? This one has a positive x over y. Some of the points are going to have the same little things on them. Some of them will be different. It is going to make another conic section. Start this one out and see if you can figure out what it's going to turn into while I hand out the homework. Okay. Here is the finished product. We're getting close to the end of class. It's supposed to look like this. You're going to have these two diagonals going this way. They are asymptotes. And then you have graph going this way or this way. What conic section looks like that? Hyperbolas do. They're the ones that go like this. Remember these? They go like this, and then top and bottom. That's a hyperbola. If you separated the variables, you will get a hyperbolic equation from that. Now, what I would like you to do is, since we've already done this on Friday, I want you to draw in the slope field right here. Do you remember what we did on Friday?
Can we get our notes later?
Of course, of course. I know it's been a weekend.
It has.
So please fill in that slope field right there, and I'm going to give you a few minutes to do that. Okay. All right. Now, just for this one problem, because it's not feasible to do it all the time, I want you to tell me if this is the derivative, what was the original equation?
X squared.
So y equals x squared plus c. So it's any parabola moved up or down. So does this look kind of parabolic shaped to you guys?
Yes.
It should. So that's why that slope field looks the way it does. Okay? Now, we're going to now look at some application problems that deal with slope fields. Let's look at the bottom. It says in exercises 1 and 2, first determine which graph shows the solution of the initial value problem without actually solving the problem. In other words, they don't want you to separate the variables. Just look at the 3 graphs and figure out which one is the correct answer. Explain why you eliminated the other 2. Okay? So here's what we're going to do. The slope is calculated with this formula at all the points on the curve, and it goes through the point 0, pi over 2. Now, do you see the point 0, pi over 2 on all 3 of these graphs?
Yes.
Okay. Now, because the graph is defined by the derivative, what I want to do is I want to estimate what the slope is at each of these 3 graphs at that point. So right here, draw in a tiny little tangent line right there. What would you estimate the slope of that line to be?
0.
0. So underneath it, write m equals 0. All right, go to the next graph. Do the same thing. Draw in a little bitty tangent line. What do you think the slope of that would be? Probably 1. And then the other one will probably be -1. You may not be exactly 1, but at least you know it's negative. Okay? They are all different. So it's going to be pretty obvious once we do the math as to which one is correct. Now what we're going to do is we're going to take and plug this point into the derivative and see what the slope's supposed to be. So I'm going to come over here and I'm going to write dy dx, and then at the bottom a subscript with the coordinates 0, pi over 2. This is the way the calculus books in college write it, equals. Now I want to take the formula and plug in the x value in question. So it's going to be 1 over 1 plus 0 squared, which reduces to what? 1. So which graph is the correct answer? B is, because it has a slope of 1 at that point. Question?
Did you just decide to put 1 B as a guess, or did you just have that?
Okay, the reason I did it for all of them is because it said explain why you eliminated the other 2. Those other slopes are why those 2 are incorrect. You see what I'm saying? So the reason we went ahead and did all 3 is because now we have a reasoning as to why the other 2 are wrong. It says the slope's supposed to be 1, that slope is 0, that slope is -1, so those 2 are wrong. Does that make sense? I don't have to write sentences out explaining that one doesn't have the right slope. I have the work right there. Any questions? I want you to do the next one, the same process. So you do number 2, calculate the slope at each of the points, give an approximation, and then plug in and see which one is supposed to be the right answer. Okay, the slope here is the tangent line, which is definitely -1 because it goes through 0, 0, and -1, 1. Here the slope is probably 1-ish, positive 1-ish. This one, it's kind of hard to tell.
-3.
So some people said -2, some people said -3, that's okay. But when you do the math, dy dx at -1, 1, it is the opposite of the x, which makes it +1, which makes it the middle one, because it's the only one that's positive. Okay? Do you have any questions on this? Okay. Turn over on the back. And I apologize for the top ones are not so hard to read, the bottom ones are a lot worse. Okay? I have to even get out my reading glasses so I can see better. All right. Now, what we are doing now is matching each of the differential equations with the correct slope field. This is not as easy. because it's a multiple number of possible graphs here. But here's what we're going to do. When you're looking at a slope field and you're looking at one of those tiny little lines, if it's slanted, you can only guess as to what its slope is. But if it's flat, if the little line is flat, you know for a fact the slope is 0. So that's what we're going to be using to judge these graphs. So what I want you to do is to look at each graph, and I would like you to put a little arrow where you see a line, either horizontally or vertically, of pieces of slope field that are equal to 0 slope. Look at letter A. How many lines do you see that have 0 slope? 2. I see one here and one here. Do you see what I'm doing? Putting the little arrows on it. Okay, what about letter B? I see 1 and it's horizontal right there. What about C? Okay, no, those are slanted up there. Where do you see it flattening out? Vertically out to the side, right about here. Any place else? On the other side, it's doing it again. So somewhere over there. Okay, and this one, vertically right there, it's flattening out. You see that? Okay. Now, that is not a guarantee. When a slope field is drawn, there's no guarantee that these are 1 unit apart. They may be 0.5 units apart. They may be 5 units apart. We don't know. So you can't count how many down it is to be sure of what the answer is. What you're going to have to do is notice we're talking 2 horizontal ones here, 1 here, 2 verticals here, and 1 here. So it depends on how many answers you get. So what we're going to do is we're going to take each one of these and we're going to take the derivative, which is the y plus 2, and we're going to set it equal to what we want the slope to be. We want the slope to be 0, and solve for y. And so we get for this one, y equals -2. One answer, and it's a y equals line. So which of the 4 graphs does it have to be? Which one has a horizontal set of these flat little lines? A has 2 of them. B has only 1, so B is the correct answer for this one. Do you see that? Only 1 set of them, and it's in the negatives. Okay, now that we have 1 answer, how far apart are these little marks? It's the 4th one down, so that means that these have to be 0.5 units apart. Does that make sense to everybody?
Yes.
Okay. Do the same thing to number 2. The derivative is x plus 2, so we want to set x plus 2 equal to 0. What do we get for x? -2. X equals -2. So we've already used B. Can't be B. Which one is it? It has to be D, because it's vertical line in the negative. So that's the correct answer, is D. All right? Number 3. 1 plus cosine of x equals 0. So cosine of x equals -1. Where is cosine equal to -1? Over here at pi. Now wait a minute. We've already used the 1, and that's positive. Could it be C maybe? Yes. Now see, that's quite a ways away. That's about 3. But why is there 2 answers? Because it could also be true at -pi. Right? Because -pi is going around the circle the other way. So that means that C is the correct answer for this one. Now I'm going to go ahead and do number 4 because I want to double check myself. And it says 1 minus y squared equals 0. 1 equals y squared. So y equals what? Plus or minus 1. And notice that there are 2 answers, both close to the x-axis, so this one does have to be A. Do you have any questions on what I did? Okay, now go down to the bottom. These are a lot harder to see, I know, and I apologize for that. We are going to omit 17 and 18. And what I would like you to do is taking the remaining 6 graphs, I want you to match them up with 13, 14, 15, and 16 exactly the same way I did. Now, Use your good teenage eyes, because my eyes are not that good, to see if you can find where they flatten out. Sometimes they flatten out on the x-axis. Look at letter F, for example. Do you see how, I mean, if they flatten on the x-axis, you can't see the little lines, but do you see how the one right above it and the one right below it are almost flat? So this one is flattening right on the x-axis. Okay? So work with your table, see what you can do, and see if you can match those up. I'll give you a few minutes to work on that. Okay. 13. Can you see what I'm writing? Yes. Sine of x equals 0. X equals 0. Flattens only at 0. A looks good, but it also flattens here, so it's not A. It's not B. It happens to be E. It happens to be E. Here's why. Here's another reason why. If dy dx is sine, listen to what I'm saying. If dy dx is sine, what was the original equation? What has a derivative of sine? Negative cosine. So the pattern has to look like a cosine wave of some kind. And the only one that does, this one's kind of going in circles. And so is this one. The only one that's making waves is E. So E is the correct answer for 13. Yes. It does flatten over here. Yes, it does. But that happens to be 2 pi. Okay? So 14. 1 minus x squared equals 0. X squared equals 1. X equals plus or minus 1. So I need one that flattens just to the left and right vertically. And that happens to be this one right here. That is B. Okay? Now, some people got to 15 and weren't quite sure how to mathematically solve this. You set each one equal to 0. So you get x equals 0 and y equals 3. There are your two answers. And that is A. That is A. And then 16, y parenthesis 3 minus y equals 0. So y equals 0, y equals 3. And that happens to be F.
Woo. So,
Yes.
what's the point of doing this?
Okay, we're doing applications, the real world use of differential equations tomorrow. Okay? These are just graphic representations of all the different possible solutions because, for example, the antiderivative of sine is negative cosine plus C. I don't know which one for sure it is, so instead of drawing in a million graphs, we draw in a million little lines instead.
It looks like a tire.
Yeah, it does. It does.
Are they using tires?
I would have to go look. I'm not sure. Matt, what was your question?
You just don't know what position they are, how far away they are. You just kind of like guess.
It is an estimated guess as to how far away they are, yes. And it has to do with how many answers and in which direction they should go. Okay? Any more questions? Yes?
Will you give us one that the two graphs look similar?
Will I give you? No, I won't. Completely different. Okay? Zach? 13. Yes, this is 0, that's pi, and that's negative pi right there. You're right. You're right. Okay, any more questions? All right.